Hi Algebra, in lesson 22 here we're going to be graphing linear inequalities, so it's going to be similar to graphing lines but with just a little twist. Here we go. In this problem I've picked out the most important information. I've done some color coding. Sod is $2 per square foot, and we're going to use X to represent how many square feet of sod. Flower beds are $12 per square foot, and we're going to use Y to represent how many square feet of the flower beds. And her budget is $3,000, and she's going to use the entire budget. All right, here's an equation. Notice there's an equal sign. It says equation, so it's not an inequality here. But it's $2 per square foot of sod, so that's 2x. $12 per square foot of flower beds, so that's 12y. We add everything together, and she's going to spend all $3,000. First thing I'm going to pick here is 0 for y, because then I know if I plug in 0 for y into my equation, I end up with just 2x equals 3,000, because 12 times 0 is 0. I divide both sides by 2. I get x equals 1,500. The next thing I'm going to pick is 0 for x, and just see if I can get a number that works out nicely. And that would end up being 12y equals 3,000. Divide both sides by 12. I get y equals 250. And so now I have my two coordinate points right here. These just become xy coordinates that I can plot on the graph. And there it is. There's the line of this equation graphed on the coordinate plane. Looking at every point that falls on this line would be a combination of a certain square footage of sod and square footage of flower bed that would get us to $3,000. Up here on your y-intercept of 250, that just means you could get 250 square feet of flower beds and 0 square feet of sod for $3,000. And down here in your x-intercept, that means you could get 1,500 square feet of sod and 0 square feet of flower beds for $3,000. Now our homeowner is worried that it's going to be too much work to keep with the flower beds, so now she's considering turf at $15 per square foot and gravel at $3 per square foot, and she still has a budget of $3,000. Here's a graph of that line showing how we could spend $3,000 on turf and gravel. In the equation here, we just need to be careful that x is the gravel at $3 per square foot. That's because the gravel is on the x-axis over here on the graph. And 15 is times y, the $15 per square foot of turf, because turf is on the y-axis on our graph. And we're still spending $3,000. The solutions are going to be any point along this line that makes the equation true. So any combination of square feet of gravel and square feet of turf that add up to $3,000. The point 600, 200 means 600 square feet of gravel at $3 per square foot and 200 square feet of turf at $15 per square foot. If I simplify this, that would be $1,800 worth of gravel and $3,000 worth of turf, which is $4,800. No, that does not meet her constraint. Her constraint was her budget of $3,000. This is well over that. I chose this point right here, 400, 150, 400 square feet of gravel, 150 square feet of turf. That would end up being $1,200 worth of gravel, $2,250 worth of turf, and it would get you a total of $3,450. So again, that does not meet the constraint of the $3,000 budget. The point 200, 100 means 200 square feet of gravel at $3 per square foot, that's $600. 100 square feet of turf at $15 per square foot, that's $1,500. That's a total of $2,100. So yes, this one works. It is within the budget of $3,000. You maybe chose a different point, but I chose this one right here, 600, 50. So 600 square feet of gravel, $3 per square foot, that's $1,800. 50 square feet of turf at $15 per square foot, that's $750. So that ends up being a total of $2,250. So yes, this one fits within that budget of $3,000. So when looking at an inequality that represents the constraints, it was $3 per square foot of gravel, $15 per square foot of turf, and we had to meet the budget, so it had to be less than or equal to 3,000. So now we have kind of that equation, but written now as an inequality because we could not spend more than $3,000. The solutions to this inequality are going to be any points or any combination of gravel and turf that end up being below our $3,000 budget. Now we need to show the solution region on the graph. So that means, where are the solutions to our inequality? Are they on this side of the line, or are they on this side of the line? And from the points that they have here and the points that we tested, we saw that our solutions were on this side of the line, because these are where the combinations of gravel and turf are that are going to be less than $3,000. So you could pick any coordinate point in here, and its x and y values are going to make this inequality true. Now the line here is the line of the equation. So the line is showing 3x plus 15y equals $3,000. Then the inequality part is this whole shaded region is showing the 3x plus 15y is less than or equal to $3,000. The line itself is a solid line, not a dashed line, because it is less than or equal to. So we want to include all of those points along that line. This last example that we're going to look at is in your lesson summary, and it's this example towards the top. It's the third paragraph from the top, and they're going to be looking at buying coffee beans and tea leaves and the budget. And so it's similar to what we were looking at earlier. Here's the inequality that they are looking at. Our first step whenever you're graphing these inequalities is to first graph it as an equation. Notice the equal sign right there. That's going to get you your line. And remember, graphing equations, find points for x and y that make the equation true. In this case, it's c and t, but you could switch that out to be x and y. Step 2 is that you're going to test points on either side of the line. So for example, here, if we plug in 70 for x and 100 for y, does it make it true? And that's what they did down here in your book. 70 for x, 100 for y, does it make it true? In this case, no, it did not. Test a point on the other side, 20 for x and 40 for y. Pick points that are easy to use. Here they plugged in 20 for x, 40 for y, and yes, it did make the inequality true. So now we know that the solutions are going to be on this side of the line in this example, and so we will shade that side. So shade the side of the line that includes the solution, showing that any point in that area is going to make the inequality true.